Okay, so we're going to continue our discussion about discrete variables here. And we're going to start talking about a new distribution called the binomial distribution. And so let's kind of make up an example here. So let's say we have a quiz, and this quiz is going to have 10 questions on it, and it's multiple choice. And there's 4 choices on it, A, B, C, and D. And we're not going to study for this. We're just going to go ahead and walk in and completely guess on this. And we want to know what is the probability that we get 7 correct. So we're hoping for a pass. We're just going to go in and completely guess out of 10 questions. And so let's use the multiplication rule first to look at this. And so the multiplication rule, if you recall, we could look at each selection independently. In this case, it's going to be each single question that we're trying to answer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 10 questions. Now, for the very first question, what's the probability that we get it correct? Well, there's 4 choices, A, B, C, D, and there's only one correct one. So it's going to be 1 out of 4. Now, for the second question, these are independent. It doesn't matter what we selected on the first one. It's still going to be 1 out of 4. And it's going to be all the way through. And we want 7 of these correct. So by the 7th question, we want to still get that one correct. And that's going to be 1 out of 4. Now that means that the remaining 3 we could get wrong at this point. And so how many solutions are wrong? Well, 3 out of the 4. So for these guys, we're going to have 3/4, 3/4, 3/4 here. So again, we're trying to get 7 questions correct here. And that allows us to free up the ones at the end to be wrong. Now, this is very specific. This is actually the case that we get the first 7 correct. We want any 7, right? I want any 7 correct, not just necessarily the first 7 correct here. So what we've done before with the multiplication rule or pulling marbles from an urn or a hat, we always said the first marble has to be red and the second one is blue. Or the first card drawn is green and then the second one is red, or whatever we're talking about. We never really allowed for the possibility that we could get any of them, right? And if we're trying to get like red marbles, that they come out really, in any order. So let's kind of write this mathematically here, what we have so far. And we're going to write correct here is 1 out of 4. And since we're going to multiply these guys out 7 times, this is technically to the power of 7. That's just going to be our shorthand. And then wrong, well, the probability is 3/4, and we want 3 of them wrong. So this right here is actually shorthand notation for all of this right here. They're exactly the same. Okay. But we have to consider, again, this is that we're getting the first 7 correct. We want any 7. So the question we need to ask here is, how many ways can we get 7 correct? And in order to talk about that, we're going to need to introduce combinations. And so this is sometimes it's called n choose x or n combination x. And this guy's equal to n factorial divided by n minus x factorial times x factorial, all in the denominator. And if you're not familiar with factorial, this is an operator, much like addition and subtraction. It's telling you to do something. So 7 factorial means you multiply that integer times every integer before it, all the way till we get to 1. So 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. N is the total number of questions that we have here. And for our specific example, Rn is going to be 10. And X is going to be the questions we want correct. So for our example, we would write 10, choose 7. So this is going to cook up any 7 correct questions that we want to get correct here. So it's 10 factorial over n minus x, which is just 10 minus 7. That's 3 factorial times 7 factorial. Note the bottom ones will always add up to that top one there. And so this top portion right here, there we go, is really going to be 10 choose 7 times 1/4 to the 7 times 3/4 to the 3rd. This is going to actually be the way that we get any 7 correct. This initial piece right here is going to make it a lot larger. There's a lot of different ways for us to get those 7 questions correct there. So we have to account for all of that. And let's introduce some notation here. So we're going to want the probability. Sorry, having a little slight issue here. Okay, and that should fix it there. All right, so this is 120 times 1/4 to the 7 times 3/4 to the 3rd. And there is a way to calculate that whole 10 choose 7 on the calculator, but we're going to even have a fast way of calculating this whole quantity, so I'll skip that for now, but I'll show you some functions on how to do that. So this will probably give us 0.0031, okay? Now this is great. We decided we're just going to go ahead and guess on this quiz here. But in reality, we don't really just want 7 questions. I mean, I'll be happy if I get 8 questions or 9 questions or even 10 questions correct. So the real thing we want to ask here is going to be the probability that we get at least 7 correct. And so if we want at least 7 correct, let me introduce some notation here. We're going to call this top portion that we just worked out the probability of x equals to 7, because x is a number of correct. And if we're going to guess, we're going to be happy if we get, more than 7, so at least 7. So that means technically what we want to figure out is the probability we get x is equal to 7 plus the probability x is equal to 8 correct plus that we get 9 correct plus that we get 10 correct. And that means we got to do all of this calculation for 8, for 9, for 10. So for the 8 case, we would have 10 choose 8, 1/4 to the 8 because we want 8 correct. And that means 3/4 because that's the complement that we're going to get it wrong, and we're going to get 2 of those wrong. And we have to do this for the x equals 9, and then again for the x equals 10 in this case. And this is going to be way too much work to do by hand. So we're going to get a little bit savvy with our calculator here. And I'll show you guys how to plug this in with a feature on our calculator here. And here we go. Okay. So the binomial distribution, formally, p of x, and this is equal to n choose x, p to the x, q to the n minus x. And this is just what we did before. If we wanted 7 questions correct, this was a 7, and then that means this was a 3, right? Just the difference of those guys. And so n is our number of trials for that last example. It was 10 questions that we had. X is number of successes, so how many we want to get correct. And P is the probability that we actually get it correct. And Q is the probability of failure that we don't get it correct, which is a complement. It's technically 1 minus P. Okay, so what we looked at was the probability x is equal to 7. That's 10 choose 7, 1/4 to the 7th, 3/4 to the 3rd. We have a feature in our calculator called a binomial PDF here, and our input for it is NPX. And this is under, if you go second distribution, it will pop up. And let me just write this in here. So for us, our N would be 10, our P would be 1/4, that we get one of the questions correct. And then X is going to be how many we actually want correct in this case here. And on our calculator, you hit second distribution, and then you're going to see a whole bunch of them. And if you scroll down, you'll see a binomial PDF. That's for the 84. But what we technically wanted was, let's look at some other cases first. What if we wanted the probability that we get 7 or less correct? So this would be the probability x is less than or equal to 7. And in this case, though, we're going to use not a PDF, but a CDF. The C stands for cumulative. So we're accumulating, starting from the very lowest value all the way up. And it's going to also be inputted as NPX. And so on our calculator, it will look as binomial CDF of 10, 1/4, 7 there. Now, the number of correct could be 0, 1, 2, 3, 4, all the way up to 10. What we wanted in this case was we wanted to get 7 or less. So we're looking at 7 or less. So all of these values over here. Now, if I use a CDF, since it's cumulative, it's going to do the case for x is equal to 7, x is equal to 6, 5, 4, 3, all the way downwards is how it kind of works there. And if we plug this in, we're going to get 0.9996 there. Let's do another one of these. What about the probability we get fewer than 7 correct? So that's a probability x is less than 7. Notice it's not equals to in this case. So we still want multiple cases, not just a single selection. So we're still going to do the CDF. But this time our N, our P are going to be the same, but our X is actually going to be 6 because we want fewer than 7, so we're not actually including it. So if I kind of write all the numbers we could get correct here, I want fewer than 7, so I'm looking for those portions there, 6 and below. Now if I plug in the number 6 into my calculator, it's going to actually include that value and everything below it. So exactly here is going to always be PDF. If we have more than one case, we're going to use a CDF. So let's do the probability we get more than 7 correct. And let me do my little sketch here first. So 1, 2, 3, 4, 5, all the way up to 10 correct here. I want more than 7. So that means I want 8, 9, or 10. Now the cumulative distribution function on your calculator only knows how to count downwards. So it starts at 0 and works its way up. So if I want 8, 9, and 10, it's not going to know how to count that top portion there. So what we're going to want to do here is get a little creative. So let me write this notation out. Probability x is greater than 7. This is what we want, the top portion. This is what we don't want. So let's calculate what we don't want here. The binomial CDF, 10, 1/4, and then 7. That's going to give us what we don't want. So to get the leftover, we could go 1 minus that. We could actually get the complement of it. And that'll give us 1 minus that 0.9996. Because we actually already calculated this value here. That was this number up here. All right. One more case. Probability we get at least 7 correct. So again, I like doing my little sketch here of all the possible ones we could get correct. I want at least 7, so that means 7 or greater. Again, we're looking at the top portion is what we want, so we're going to have to use a complement by calculating what we don't want. So this is a probability x is greater than or equal to 7. So 1 minus the binomial CDF, still CDF because we're accumulating, it's not in exactly one case here. But what I'm going to plug in this time is going to be a 6 there, because we do not want that. And if we plug in a 6, it's going to calculate all of this portion right here, which is what we don't want. And that's why we have the 1 minus piece. And then that should give us roughly 0.0035. Oops. There we go. Okay, and I think I had to make a slight correction on my decimals there. Okay, so here's a question, and you guys could go ahead and pause it and try to answer them. And I'll go ahead and get involved here. Okay, so part A, we know it's binomial because there's two options. Either you save or you spend. So buy meaning 2, and there's only going to be 2 options there. And X is going to be the number of people that end up saving here. That's what we're calling a success. Our probability of success shows 60% there. So that's where we're getting the 60 from. And N is going to be our sample size. And in this case, we asked 50 people here. And our probability of failure that they don't save would be the complement of that. Okay, for part B, we want probability that 25 adults in the sample prefer saving. So this is an exact, it says exactly 25. So we're going to go ahead and use a PDF in this case. And our sample size probability of success in 25. And if you plug that into our calculator, that should spit out what we have there. For the next one, we want at most 20. So that includes 20 and below there. So we're going to go ahead and use a CDF because it's cumulative. It's more than one case here. So we want 0, 1, 2, 3, 4, 5, all the way to 19. And so we're going to go ahead and plug in 20 there. And then for part 3, we want more than 30. So more than 30 here. And so that means we want 31 and above. So that's what we want. We don't want the bottom case. But our calculator only knows how to calculate the bottom portion, so we're going to have to use our complement. So this is going to give us 1 minus the binomial CDF, and again, still CDF because it's cumulative, of 30 in this case. So that gives you 1 minus 0.5535. 0.4465. And for part C, we could get the mean of a binomial distribution by multiplying n times p and the standard deviation by the square root of n times p times q. So these are some simple calculations to get the mean and standard deviation, because ultimately those are the characteristics we're interested in data here.